Hello viewers, welcome to my channel. Well, today I'll be teaching you how to draw your ray diagram. The first part will be for the mirror, while the second part is going to be for lens. So we have two circles. Let's assume this part is the back of the mirror and this part is the back of this mirror. We have a line that cuts through the center. Let's assume this is the center. We call this the center of curvature, being that this is the center of the curve of which this mirror is part of. This is the center of a curve of which this mirror is part of. Halfway through this is called the principal focus. Here is the center of curvature. This point where the line touches the mirror is called the pole. This straight line that cuts through the mirror is called the principal axis. So let's spell it all out. We have the C, then we have the F and the P. These two mirrors we have in here have a name: convex mirror, the concave mirror. You can see the way it's curving word, so it's called a concave. This is convex. Let's proceed to the drawing. The first mirror. So we have the center of curvature, and we're going to draw a line that cuts through. Halfway through is, say, here. So this is our principal focus, and here is our pole. Of course, to show it's a convex mirror, we have to shade the other part. Let's assume we have an object placed at any point in front of this mirror. Simple rule we use in solving problems like this. Let's assume the object is here at some point on the principal axis. The first rule says that the ray parallel to the principal axis, which is this, will strike the mirror and then would reflect through F. So the ray has struck the mirror. Since this is F and it's behind the mirror, it's expected that it goes back this way. And because this is behind the mirror, the only thing we need to do is make it a broken line. The second rule says a ray must pass through C and must reflect along the same path. This is C and this is the top of the object. At this point of intersect between the two rays, from what you see here, the first ray came from the top, struck the mirror, and it's going back. The second ray is coming from this part through C and is going back. The general characteristics of image formed by a convex mirror is one, that the image is diminished. Secondly, because it's behind the mirror, the image will be virtual. And thirdly, the image will be upright. Let's look at concave mirrors. So let's start. We have the center of curvature. This is the pole. Halfway through is the principal focus. Just as we had in the convex mirror, the same rule guides here. Let's say we have an object of height 1 centimeter. Let's take the same 1 centimeter across. Following the first rule, it says that the ray parallel to the principal axis, after striking the mirror, will reflect and cut through F. Second rule says that the ray will pass through C, then strike the mirror and come back along that same path. This point of intersect is where the image is being formed. The characteristics of this image formed will be: 1. The image will be diminished. The image will be inverted. But because it's in front of the mirror, it's going to be real. Let's go to the second one. If the object is at C, so let's follow the rule once more. The ray parallel to the principal axis will strike the mirror and it's going to cut through F. Since it can be going through C this time around, we have to send it back here. Then we have to link it so it becomes parallel to the principal axis. The image is inverted, but about the same size as the object. Let's check. See, it's about the same size. See, it's about 1 centimeter. The characteristics of the image formed when the object is at C is 1. The image will be inverted. 2. The image will be about same size, will be the same size as the object. And 3, it will be real because it's in front of the mirror. Let's go to the third one. Let's say we have that same object. From the rules, it says that the ray parallel to the principal axis will strike the mirror and cut off at F. The ray traveling here strike the mirror and is going back. Now the second rule says the ray will cut through C, strike the mirror and go back along that same path. So the image from the top will go to the top, strike the mirror and comes back along that same path. This point of intercept is where the image is going to be formed. So the characteristics of the image formed when the object is between C and F is 1. The image will be real, it's going to be magnified, and it's going to be inverted. So let's do the third one. When the object is now at F, the top of the object, strike the mirror and cuts through F. The second rule says that the ray will strike the mirror and come back along that same path. The nature of this image formed is at infinity. And so when the object is at F, the image is at infinity. You can see the line doesn't intersect, it just goes through. So we have this here between F and the pole. So following the rules, we have the ray striking the mirror and it's going to reflect passing through F. The second rule says it's going to strike the mirror and go back along the same path. Observe that this ray and this one looks like they're going to converge somewhere. So let's try and make that up. Wow. So you can see there's a formation there. So the characteristics of the image formed when the object is between F and P is 1. The image is magnified. Secondly, it is upright, which is totally different from every other image formed. Alright? All along the image has been inverted and real. In this case, you see that the image is upright, and because it's behind the mirror, it is virtual. So let's try one other case. So what happens when the object is at infinity? If it's at infinity, we'll consider this. First, the ray will come through the center and go back along the same path. Secondly, the other ray will come through F and become parallel to the principal axis, or vice versa. Or it could come the other way around as well. Something. The image is formed here, right on F. So you would see that when the object is at infinity, the image will be formed at F. So 2 formulas will be needed to solve any problem presented to you in terms of ray diagrams. The first is the mirror formula, which is where F equals U equals the object height or distance, V image height or distance. The second is the linear magnification, is M, where M is magnification, equals image distance over object distance, or image height over the object height. Now this mirror formula can be solved in two different ways. The first is real is positive, 2 is a new Cartesian method. So you could use any other method, whether real is positive method or new Cartesian method. So if you want to use real is positive, you have to specify while solving problems like that, right? Real is positive says that for the fact the image is real and not a virtual one, for the fact it's real and not virtual, the image will have to be a positive sign, which is this is correct. But if the image is a virtual one, you will now have a negative sign, which means this sign here changes to negative. But for the new Cartesian method, it says that since the image is on the left-hand side of a graph, it's like you're plotting a graph, negative, positive. Since this image is on the left-hand side, it's going to be, the image is going to be negative, which means this sign changes to negative. But if it's on the right hand side, like this virtual, it's going to be positive.